Hey everyone, today we are going to talk about cofunctions and quadrantal angles. Please make sure you have the note sheet printed off before you watch this video. You can fill in the notes as we go through this. So we'll start with cofunctions. Cofunctions is any trig function of an acute angle is equal to the cofunction of its complement. I'm going to explain what that means here. So if I have a right triangle, oops, here's my right triangle, and say I have a 3, 4, 5 right triangle. If I call this angle theta, I know that these two angles here have to add up to 90, which means that this angle here is going to be 90 minus theta. So if this angle was 40, this angle would be 50. Then this angle was 20, this angle would be 70. Okay, so that's the idea behind that. So now that we have everything labeled, let's go through our trig function. So let's start with sine. And if I asked you what the sine of theta was, you would say, well, sine is opposite over hypotenuse, so that would be 4/5. Okay, if I then asked you, well, what is the cosine of the angle 90 minus theta, right? That's that angle up there. Remember, cosine is adjacent over hypotenuse, so the adjacent side to that angle would be 4. So that would be 4/5. So what I can say then from that is that the sine of theta is equal to the cosine of 90 minus theta. Therefore, sine and cosine, excuse my bad handwriting here, are cofunctions. That's a really bad handwriting. It's hard to write on this thing. Okay, sine and cosine are cofunctions. Okay, let's then look at let's go with tangent. So tangent of, just had a brain cramp there for a second. So tangent of theta, remember tangent is opposite over adjacent, so that would be 4/3. And cotangent, right, you learned about your reciprocal trig functions. Cotangent flips tangent, so cotangent instead of 4/3 is going to be, oops, hold on, let me back up here for a second. I don't want to do cotangent of theta, I want to do cotangent of 90 minus theta. Okay, so cotangent of 90 minus theta would be opposite, right, tangent would be opposite over adjacent, that would be 3/4, but cotangent flips tangent, so that would also be 4/3. And so we can then say that the tangent of theta is equal to the cotangent of 90 minus theta. Therefore, that's those 3 dots. Tan and cotan are cofunctions. Hopefully you're seeing the trend here, right? Sine and cosine are cofunctions. Tangent and cotangent are cofunctions. I'm sure you can then kind of guess what I'm going to do for the next one, right? And I'm going to try and squeeze this in here. The next one would be secant of theta. So remember, secant flips cosine, right? So secant, cosine would be adjacent over hypotenuse. So cosine would be 3/5. Secant flips that, so secant of theta would be 5/3. Right? So the cosecant of 90 minus theta, remember cosecant from yesterday, cosecant flips sine. Okay, so whatever the sine of 90 minus theta is, sine would be opposite over hypotenuse, so that would be 3 over 5. Flip that, and you also get 5/3. So we can say that the secant of theta is equal to the cosecant of 90 minus theta. And therefore, secant and cosecant are cofunctions. And so what does that mean? That means if you are talking about an angle and its complement, right? So two angles are complementary if they add up to 90. Their trig function, the trig functions that would be equal are the cofunctions. So the sine of 30 is going to equal the cosine of 70. Okay, or the tangent of 60 is going to equal the cotangent of 30. Those two angles have to add up to 90 degrees. So let's go through a couple of examples here. It says, express the sine of 76 as a function of an angle whose measure is less than 45. Okay, so because I know that cofunctions are equal to each other, I know that the sine of 76 is going to equal the cosine of 90 minus 76, which would then give me the cosine of 14, and that gets me my angle less than 45 degrees. So I literally have the cofunction, but the angles are complementary. And this is an easy mistake to make. Sometimes people say the sine of 76 equals the cosine of 76. That's not true. Okay, it's their complement, the cofunctions and their complements. So let me show you on a calculator here. If I put in the sine of 76, that's 0.5661. And if I did the cosine of 14, and that, I think my calculator is in the wrong mode. Hold on one second. Oh, my calculator is in radians. I have to do this in degrees. Okay, let's try that one more time. So the sine, I know you're like, wait, you just said it would work. Hold on. Sine of 76. There you go. And then let's do the cosine of 14. Okay, so you see there that they come out to be exactly the same. That other measure, the reason it didn't work out the first time was because it was in radians, which we haven't talked about yet, but we'll get there. Okay, so let's look at another one. The next one here says, express the tangent of 83 degrees, 22 minutes as a function of an angle whose measure is less than 45. Okay, so when we are talking about degrees, 60 minutes is equal to 1 degree. It's just another unit of measure when you're talking about angles. So 60 minutes, we use a tick mark to label minutes, is equal to 1 degree. And so we would then say, okay, well, the tangent of 83 degrees, 22 minutes, has to equal the cotangent, because they're cofunctions, of 90 minus 83 degrees, 22 minutes. And so you might say, I don't even know how to go about doing that. Well, think of it this way. The cotangent, I can rewrite 90 degrees because 60 minutes is equal to 1 degree. I can rewrite 90 degrees as 89 degrees, 60 minutes. That's the same as 90 degrees. So 89 degrees, 60 minutes minus 83 degrees, 22 minutes. And so then it makes that subtraction a little bit easier. So that would give me the cotangent of 89 minus 83 would be 6 degrees, and then 60 minutes minus 22 minutes would be 38 minutes. Okay, so the takeaway here is that if you take any trig function of any angle theta, that's going to equal the cofunction of the complement of that angle. Okay, so I'm going to stop this video here, and the next video is going to have the rest of the notes in it.